Hello everyone, welcome to Computer Science 227, lecture number 4. Okay, today we'll be talking about interfaces. Last time we were talking about abstract classes. Today is interfaces turn. Okay, so again, what did we learn last time? So abstract classes are created to be extended only. So in this case, a geometric object, right, is too abstract to be instantiated. It's not really clear what it means, right? But we can extend it in a circle class and in a rectangle class. Okay, and in that case we can instantiate a circle and a rectangle, but we cannot instantiate geometric object. Okay, now talking about interface. Okay, interfaces. That is a even more rigorous, even more strict, kind of a stricter version of abstract classes. Okay, so if I draw a line, kind of like a rigor. Okay, so let's say this is rigor. Hold on. Okay, rigor. No, doesn't work. 1 second. So again, there is a line, right? And we're talking about how rigorous it gets. Okay. So here we would have like normal classes. Here we would have abstract classes. Here we would have interfaces. Okay. So just classes. Okay. Here we would have abstract. Hold on. Okay, we have abstract classes, and here we would have interfaces. Okay, so what does it mean? That means that in classes, you're basically allowed to have everything. In abstract classes, you're allowed to have abstract methods and regular methods, and in interfaces is the same thing, but in interfaces you're allowed to have only abstract methods and the final variables, which means constants. Okay, so again, in classes you can have all of them. Well, although if you have an abstract method, then that class has to be an abstract class. Okay, but anyway, it's more flexible. In an abstract class, you're allowed to have regular methods, abstract methods, constants, and regular variables. And then interfaces, you're allowed to have only. So it's very strict version of an abstract class. You're allowed to have only abstract methods, and only final variables. That's it. Well, final variables meaning constants, right? So the variables, values of which you cannot change. Okay. Yeah, so class-like construct contains only constants and abstract methods. In many ways, an interface is similar to an abstract class, but its intent is to specify common behavior for objects of related classes or unrelated classes. For example, using appropriate interfaces, you can specify that the objects are comparable, edible, or clonable. Usually, interfaces are written as adjectives, like what you can do with it. Okay, so for example, edible, right, which means you can eat it. Comparable, which means you can compare it. Clonable, which means you can clone it. Okay. To distinguish an interface from a class, Java uses the following syntax. Okay, modifier, which means public, right? Interface, and then interface name. Okay, hope it makes sense. Okay, yeah. So all the fields, okay, have to be public static final, okay, and methods have to be public abstract. But due to that fact, right, due to the fact that all of them have to be that way, technically you can actually avoid it, which I would not recommend. So technically you can say public interface T, you can say just in regular, like as you would regularly would, int k is equal to 1. Just keep in mind that if you said that it's an interface, in this case that k is going to be a constant, it's not going to be a variable. And this method p is going to be an abstract method, okay, although you don't say that, okay. So that may be very confusing in my opinion, so my recommendation is to never do that. Always spell it out this way. Always spell it out. Always say public static final, and always say public abstract, and then put the method name. Okay. Yeah, so technically those guys are equivalent, but I would highly recommend sticking with this because it can be confusing, especially when people forget or don't really know how interfaces work. Okay, so the practice exercise for you, I want you to do that at the end of the lecture after you listen to me. But let me give you an example. So okay, what do we have? So before we're talking about abstract class, right? So let's talk about abstract class. Okay, I don't know. Let's say human. Okay. And now let's talk about in an interface. Interface. And again, here we usually put an some kind of adjective. Let's say clone. Well, clonable isn't the best one because it's a keyword. Clonable is already created inside of Java. Let's do clonable 2. I don't know. Yeah, clonable 2. Let's do that. Okay. Okay, so if I run this code, it's going to be absolutely valid. I don't really have anything inside, so there is nothing which breaks any rules. Okay. Now let's do something useful here. First off, what is the point of interfaces? What is the purpose? Why do we need them? Usually, well, first off, how do you extend it? Okay, so normally we would say, for example, class human extends, okay, clonable, right? That's what we would normally do if a clonable 2 was a class. But clonable 2 is an interface, that's why instead of extends, we need to use another word, which is implements. Implements. Okay, it's another keyword. What's nice about interfaces is that you can implement multiple interfaces. So in Java, okay, very important point. In Java, you cannot extend multiple classes, but you can implement multiple interfaces. Okay. So if I want to extend, let's say I have another class. Let's say I have another class. Okay, let's do mammal. Okay. So if I do mammal here, okay, extends, right? And then maybe mammal 2, whatever that would mean. Okay, mammal. Yeah, so if I do this, that will be valid, that will be fine. That's allowed. Now, if I do mammal and mammal 2, that's not going to be allowed because in Java, I'm not allowed to extend multiple classes. Okay, keep in mind that the error which is shown here is not really useful. It's not really helpful. Okay, so when you're looking at it, it's not really clear what it means. But what Java is trying to say is that you cannot extend multiple classes. However, you can implement multiple interfaces. So if I say implements, right, here I can have a comma-separated list of all the interfaces which I implement. For example, clonable 2, and then let's say clonable 3. Okay, clonable 3. Okay. And this will be fine. Yep. Okay, everything is good. Okay. Next, why do we need interfaces? What is the point? Usually, usually I would say most of the interfaces contain only one method. That's it. Okay. For example, clonable, right? So public, again, if I'm inside of an interface, it has to be an abstract method, right? Public abstract, void clone. Okay, like this. Okay. And in this case, if a class human implements a method interface clonable, that means it needs to give the body to the method clone to. Okay, it is absolutely required, which means I need to take this one. I need to provide. Well, if it's an abstract class, I don't think it's necessary, but for a regular class, it definitely will have to be. Okay, so here I would have to provide the body for the clone. Okay, so let's have to say public void clone 2. Okay, and let's say it does nothing. Okay, perfect. Now let me try to comment that out. Do you think it's going to work? No, it will not. It's not going to work because Why? In the interface clonable2, I have a method, abstract method clone2, okay, which doesn't have a body, which is not provided with any details in the class human, which extends clonable. Okay, so usually the way kind of it works in reality in the industry, whenever we're talking about interface, usually contains only one method. Okay, and when I say that, well, how do I say that? So if I'm a manager and I have a team of developers, I'll come to them and I say like, hey, for example, like you, John, I want you to create a class called human, and it's very important for me that he would create a method called clone2. Okay, so in order for him not to forget that, I would say that, hey, I want you to implement in an interface called cloneable2. Okay, and then John, when he creates that human class and implements cloneable2, right? Because I told him that he will not be able to make this code work without the method clone2. Okay, so it's a very, very strict reminder. In other words, okay, you're definitely required. If you say that you implement an interface, you're required to provide all the details for the methods inside of that interface. And usually, again, realistically, interfaces contain only one method. Well, of course, although again, you're technically allowed to have any number of constants and any number of abstract methods. Sorry, hope it makes sense. Okay, moving on. Yeah, so a class can implement multiple interfaces, but can only extend one superclass. Okay. So let's see. So we have abstract class and an interface. Okay, so what's the difference between variables? Okay, there are no restrictions on the variables in abstract class. So abstract class can contain any number of variables and any type of variables. In an interface, all variables must be public static final, which means they will not be able to be changed. Okay, finals. Constructors. Okay, in an abstract class, constructors are invoked by subclasses through constructor chaining. In an interface, there are no constructors at all because you can't really have a constructor being an abstract method. Methods, there are no restrictions. In an interface, all the methods have to be abstract. Instance methods. Okay, hope it makes sense. I would honestly highly recommend playing with it. So for example, try to create an interface which would have one of the methods, not that, well, one of the variables, not that way. Okay, so for example, try to create it like, well, try to say this, okay, and that shouldn't work anymore because it's not a constant. Okay, so you see they expect an equal sign. Okay, so let's say k is equal to 1. That should be fine, right? And again, it can be confusing because technically the interface is supposed to have only finals, which means constants, right? But okay, whatever. So let's say here k is inherited, right? So this k is inherited into human. Okay, similar to when a class extends another class. But now here, try to change k to 2. You will not be able to do that. Okay, so you see that's not allowed. Why? It doesn't even say that. Okay, yeah, it doesn't say that. But the reason is because again, that k is a final variable, which means it's a constant. A constant cannot change, right? Like a pi. Pi is 3.14. It cannot change. Okay, moving on. Yeah, so Java allows only one single inheritance for the class extension, right? So again, you can extend only one class, but allows multiple extensions for interfaces. Okay, so here's what you can do, absolutely legally. Public class, new class, extends only one class, okay, but implements multiple interfaces. That's allowed. In general, interfaces are preferred over abstract classes because an interface can define a common supertype for unrelated classes. Interfaces are more flexible than classes. Examples. Examples. Okay, calendar and Gregorian calendar classes. So Gregorian calendar is a concrete subclass of an abstract class called calendar. So let's see. Let's go to Google and let's type Java calendar class. Okay. Okay, and so that is the documentation for it, but does it say abstract anywhere? Yeah. Okay. So you see here it says like that the header of the file is public abstract class calendar. So calendar is an abstract class, which means it cannot be instantiated, right? And now if we talk about Gregorian calendar, by the way, you can see it here. Okay. Direct known subclasses. Okay, Gregorian calendar. So Gregorian calendar actually extends calendar class. Public class Gregorian calendar extends calendar. Okay. So that's a very popular example of abstract class. An abstract class. Okay. Yeah. So what do we have here? Okay. So we have a calendar. Get, set. Okay. So it all comes to the day and the time in the calendar. Well, not time, just the date. Add field, get time, okay, and set time. Those are the methods, public methods that you have in a calendar. Okay, in the Gregorian calendar, you have a couple of more constructors. Okay, Gregorian calendar, specific constructor. Okay, parameterized constructor. So with the year, with the month, with the day of the month, and Gregorian calendar also with the hour, minute, and seconds. Okay. Cool. Perfect. Okay. Again, two very good examples. Calendar, Gregorian calendar. Calendar is an abstract class. Gregorian calendar is an concrete class, which extends calendar. Okay, so here's what I want you to practice with it. Okay. Also, please do that after you watch this video and take notes. Comparable interface. Okay, so as I said before, most of the interfaces have only one method. Okay, and comparable interface is the interface which is which is available in Java. Okay, already. Yeah, and the only thing it does, okay, is has a method which, if you are going to implement that interface, you have to give details, give the body for that method, which is called compare to. Okay, suppose you want to design a generic method to find the larger of two objects of the same type, such as two students, two dates, two circles, two rectangles, two squares. Okay, it's a very challenging task because like larger, right? What does it mean in terms of students or dates? Okay, in order to accomplish this, the two objects must be comparable. Comparable. So the common behavior for the objects is to be comparable. Java provides comparable interface for this purpose. The interface is defined as this. Okay. So if I say that, for example, implements comparable like this. In this case, this class human will need to have the method called compare to. I will not be able to have it like that. Okay, so human is not an abstract class, does not override abstract method called compare to object incomparable. Okay, so you see I have to have this method. Okay, so public compare to object E. Okay, so okay, and here we need to public we need to return, what do we need to return? Integer. Okay, so we need to return integer. Okay, and I'm going to return 0. Okay, and now it should be fine. Now Java's not going to have any complaints. Perfect. Okay, cool. Hope it makes sense, right? So again, once I say that I implement comparable interface, that means I need to have this method, which means I need to give the body for the method, right? Which means I need to eventually return an integer. Moving on. Yeah, so comparable interface is a generic interface, okay, which means it has the generic type E. Okay, I hope you remember that from 2226. It is replaced by concrete type when implementing this interface. Many classes in Java library implement comparable to define a natural order of objects. Okay, how else are you going to compare them, right? The classes byte, short, integer, long float, double character, big integer, big decimal, calendar, string, date, all of them implement comparable interface. If you ever not sure about this, here's what you can do. You can say, for example, okay, big decimal, does it implement comparable interface? You can always go to Google. You can say Java big decimal. Okay, now you'll follow the first link, which has the official documentation, and then here you would go over here. Yeah. So public class big decimal extends number and implements comparable to big decimal. Perfect. Okay, and here are specific examples. Okay, so integer extends number, implements comparable on an integer, right? So you'll be able to compare two integers. Big integer with big integers, date with date, string with string. Okay. Same thing, exercise, practice, make sure you understand how that works. Cloneable interface, okay, pretty much the same thing, but here we should be able to clone objects. Clone, not compare, but clone, okay, so-called deep copy. You should be able to do such a deep copy. Okay, so it is often desired to create a copy of an object. To do this, you need to use clone method instead of for the cloneable interface, right? So clonable. If we do it this way, let's see if it's given by default in Java. For some reason it's not highlighted. Can't find symbol. Okay, so it doesn't know what it is. Clonable, clone. Okay, perfect. Yeah, that's what I thought. Yeah, cool. So here, though, you see this interface is empty, completely empty. So it doesn't even have a method. Okay, why? Because clonable, you can't really attach it to. You can't really create a signature which would always work. Okay, so you can't even create a signature of a method. So that's like a pretty weird combination. You have an interface if you which doesn't have anything inside, right? So if you implement it, like here, technically you don't have to add any methods at all, and you will not have any errors, okay? Which is weird, but the whole idea is that that's going to be a reminder to you that you need to create a method which will be called clone, okay? Public, I don't know, object, clone, like this. Wow, like that. Okay, and you would return, I don't know, new object. Something like this, okay? So you should be able to return, I guess, clone an object which you are inside of. Okay, so the whole idea is this. If I have a human, right? So I would say human h1, well, it's John is equal to new human, okay? And then I should be able to, Tom, I should be able to say John.clone, okay? And what it means though, what it means to clone an object, clone a human, that should be specified here. Okay. And maybe here you can say human. Okay. That's the whole idea. But again, just the way the cloning works, you can't really create a very good signature for it. That's why the clonable interface is completely empty. Okay. Yeah, so here's how it's defined. This interface is empty. An interface with an empty body is referred to as a marker interface. Okay, a marker interface does not contain constants or methods. Okay, so basically empty. It is used to denote, okay, so again, a reminder, that a class possesses certain desirable properties. A class that implements clonable interface is marked clonable, and its objects can be cloned using clone method defined in an object class. Okay, and here I have two more exercises for you. Okay, so here you see like deep copy. So in order to perform a deep copy, I highly recommend like looking it up in the internet. What does it mean? But basically, a deep copy means you're going to copy all the content from one object to another object completely. Cool. Okay, perfect. Hope it makes sense. Um, Please take notes, submit them by the end of Friday. Okay, I'll provide one more video for you from YouTube also talking about the interfaces, and I'll see you guys later. Bye bye.